Alright, so I'm going to continue now and try to do this problem. Alright, so we have events A, sorry, say good day after Thanksgiving, and B, good rest of holiday season. Alright, those are not the exact words, but the point is there. Alright, so it tells us in the past 55% of the revenues on the day after Thanksgiving were good. So probability A 0.55, while 60% of the revenues for the rest of the holiday season were good. So B 0.6. 1/3 of the days after Thanksgiving that were not classified as good, right, were also followed by holiday season, the rest of the holiday season, essentially by a holiday shopping season after Thanksgiving that were not classified as good. Alright, so the probability that the rest of the days are not good, given that we had a not good day after Thanksgiving, is 1/3. Alright, and on the basis of this information, we make a table. Alright, so I've copied and pasted that information here so that I can see it while I'm making my table. Alright, probability of A 0.55, therefore A bar 0.45. Probability B 0.6, therefore B bar 0.4. And we're given the probability, a conditional probability of B bar given A bar. So to use that in a formula, we'll have those two events, probability of A bar and B bar on the left is equal to the probability of A bar, since the probability that we now want to use A bar given B bar, B bar given A bar is conditioned on A bar, right? So A bar first here, B bar first next. So A bar 0.55 times so our probability of A bar is 0.45 times B bar given A bar is 1/3, and so the answer to that question is 0.15. So A bar and B bar is 0.15. Alright, so we have one element in the table, then we can fill out the rest. Okay, and there's our table. Okay, so let's look at these questions. Alright, part A, good day after Thanksgiving, which is event A, and a good day and a good rest of the holiday season after Thanksgiving, and that's B. So that's A and B, part A. So we want good both after the day after Thanksgiving and the rest of the holiday seasons. All right, A and B is the top left-hand corner there. That's table, and that's 0.3. All right, question B, of a good day after Thanksgiving or, all right, a good day, a good rest of the holiday season. So that's A or B. All right, so the first one was A and B. All right, A or B, the addition rule. It's probability A plus the probability of B minus the probability of A and B. All right, so let's have a look at the table. right? A is 5.5, B is 0.6. And A and B 0.3. And that looks quickly to be 0.85. Let's have a look at that table. Right, A or B. Right, A or B is this here. Right, and that does indeed add up to 0.85. C of a rest of holiday shopping season after Thanksgiving was not classified as good. B bar, not good, given that the day after or after the day after Thanksgiving is not classified as good. So it's given that, etc. The day after Thanksgiving not classified as good. All right, so we're looking for B bar given A bar. Formula: A bar and B bar divided by, right, it's conditioned on the left there, A bar and B bar is 0.15 divided by A bar, oops, wrong one, A bar sorry, let's have a look at that again. A bar and B bar, 0.15, right, divided by the probability of A bar. Okay. So 1/3, and that sounds suspiciously like one of the things we were given, right? B bar given A bar. Let's have a look. And there it is. All right. Sometimes that'll happen. Okay, D of a rest of holiday shopping season after Thanksgiving, which is classified as good. B, after, or given that, the day after Thanksgiving was classified as good. All right, so B given A. Alright, so again, the probability of A and B divided by the probability of A. Let's find our table. A and B is 0.3, probability of A is 0.55. Alright, my calculations tell me that it's 0.45, sorry, 0.5454 recurring. Alright, so 4 places that's 5454. E of a rest of holiday shopping season after Thanksgiving, which is not classified as good. That's rest of holiday season not good. After the day after Thanksgiving is classified as good. All right. B bar given A. Should notice at this point, after several of these, that we have two back-to-backs here, both conditioned on the same thing. All right, so we're only looking at those Thanksgivings, which had a day after Thanksgiving, which were good, and then we're looking at the complement of pod D in a sense. All right, so B bar given A. Of course, we could turn around and just say it's a complement of the one above, but just to show you that you can do it the long way also, it'll be A and B bar divided by probability of A. Alright, A and B bar 0.25 divided by the probability of A, which is again 0.55. Okay, and the answer to that is 0.4545, etc., but rounded 4546, and again, that is the complement of the one above. Okay. Next question. Where is it? F are the events, in quotes, the rest of the holiday shopping season after Thanksgiving, which is not good. All right, that's B bar. And the event the day after Thanksgiving, not good. A bar, mutually exclusive. Okay, so are B bar and A bar mutually exclusive is the question. If those two events, B bar and A bar, are mutually exclusive, then probability of those two events, B bar and A bar occurring, is equal to 0. But we have no such things on our table. No zeros, that is. B bar and A bar. Find the table. B bar and A bar is 0.15. Not 0. So those two events, B bar and A bar, are not mutually exclusive. Okay. And last part G, is there a relationship, dependence, between how good the revenue is on the day after Thanksgiving, A, and how good the revenue is the rest of the holiday season, B. All right, is there a dependence? Question is asked differently than other times. All right, so the question is essentially, are A and B dependent? So we'll answer the following. If A and B are independent, then the probability of A and B is equal to the probability of A times the probability of B. Probability of A and B is 0.3. Probability of A times the probability of B. A is 5.5, B is 0.6. Okay, which works out to be 0.33. 0.3 is not equal to 0.33, so alright, so A and B are dependent, or you can say not independent, but in this case, nicer still, you can say A and B are related. Of course, that relationship, the type of relationship, you'd have to go back and see if it's positive or negative in a sense. In this case, it is. It's hard to tell without looking at it deeply. But anyway, they are related. Okay. Anyway, but that's the end of that question, and that's the end of this video.